In this video, we are going to look at solving a quadratic equation with factoring. I have a quadratic equation here, and I want to solve it for x, which means I want to isolate x on one side of the equation. Or in other words, I want to find out what value for x is going to make the left-hand side the same as the right-hand side. I'll start by combining my terms together on one side of the equation. The reason I'm going to do that is because I want to manipulate this so it's in a form that looks like this, where I have something inside of parentheses multiplied by something else inside parentheses and set equal to 0. We set up things in this form in order to be able to find out what the x-intercept of the graph was. We're going to do the same thing now to solve it. So I'm going to move my 5x and my negative 30 so that those values are combined with the values on the left-hand side. So I'm going to start by subtracting 5x from both sides. And that's going to equal x squared. 15x subtract 5x is 11x. And subtract 6. And then on the right-hand side, 5x subtract 5x is 0. And I have negative 30 left over. The next thing I'm going to do is I'm going to add 30 to both sides. Because remember, I want to make the right-hand side 0, just like I have in the form up here. So now I have x squared plus 11x. Negative 6 plus 30 is equal to 24. And then on the right-hand side of the equation, negative 30 plus 30 is equal to 0. So now I have x squared plus 11x plus 24 is equal to 0. We're part of the way there. We have 0 on one side of the equation, but we need to break out this expression into factored parts. So in order to do that, I want to find out what are two numbers that when I add them together, I get 11, and when I multiply them, I get 24. I'm going to make out a little list of numbers here, numbers that multiply to 24. So 1 times 24 equals 24. 2 times 12 equals 24. 3 times 8 equals 24. And 4 times 6 equals 24. Now, two negatives multiplied together will make a positive, and so negative 1 times negative 24 is equal to 24. But if you'll notice, I have a positive value here. This is positive 11. If I add two negative numbers together, I'm not going to get a positive number. And that pattern continues here. Negative 2 times negative 12 is equal to 24. But when I add two negatives together, I'm not going to get a positive number. So these two factors, those are not going to work, and neither will negative 3 times negative 8 or negative 4 times negative 6. So I'm not going to continue that here. I have my four pairs of numbers here, and I want to find out which pairs, when I add the two numbers together, equals 11. So 1 plus 24 is equal to 25, so that doesn't work. 2 plus 12 is equal to 14, so that doesn't work because 14 is not equal to 11. 3 plus 8, oh, this looks promising. 3 plus 8 is equal to 11. So these are the two numbers that I want because 3 times 8 multiplies to 24, and 3 plus 8 adds together to 11. So again, these are the two numbers I want, 3 and 8. And so I can rewrite this expression or this equation here as x plus 3 times x plus 8. X plus 3 times x plus 8 is equal to 0. I just took this expression here, x squared plus 11x plus 24, and factored it out into these two factors. So I could check my work here and I could multiply this back out to make sure that I get this, but I've shown how to do that in other videos, so we will skip that step here. Now that I have this quadratic expression broken out into factors, I can use it to figure out what values for x will make the left-hand side equal to 0. And in order to figure that out, we're going to use something called the zero product property. And remember, the zero product property just says that if you have two things, two numbers multiplied together and they equal 0, then it means that one number or the other number or both of them are equal to 0. 0. So if we can figure out what makes this set of parentheses equal to 0, then we'll know that we found a solution. And similarly, if we can find out what makes this set of parentheses equal to 0, we'll know we've found another solution. So I'm going to do that here. We might be able to just look at this and see, well, if I substitute in a negative 3 for x here, then negative 3 plus 3 is equal to 0. And so the left-hand side will simplify to 0. But let's actually use algebra here. So if I have x plus 3 and I want to find out what value for x is going to be equal to 0, then I can just subtract 3 from both sides. And then I'll have x is equal to negative 3. So that's one of my solutions. X is equal to negative 3. Because if I substitute in a negative 3 for x here, then this set of parentheses is going to be equal to 0. And then it will multiply to make 0 here. And so I'll have the left-hand side equal to 0. Let's find out what value for x will make this set of parentheses equal to 0. I'll do that, and I'll use the same color. So I have x plus 8. I want to find out what value for x is going to make x plus 8 equal to 0. Subtract 8 from both sides. And then I have x is equal to negative 8. So these are my two solutions. I have x is equal to negative 3 and x is equal to negative 8. And so both of these work. So I'm going to say or there, and then I'm going to put a little crooked box around this, because this is my solution to this equation here. And let's not lose sight of the fact that by solution I mean that if I substitute in a negative 3 for x, for all of these x variables, then I will end up with a true statement. Similarly, if I substitute in a negative 8 for all of these x variables, then I will end up with a true statement. But let's not take my word for it. Let's actually verify that these solutions work. And so over here, we're going to verify that x is equal to negative 3, that is one of our solutions. I'm going to draw a better line there. Okay, we're going to verify that x is equal to negative 3. So I'm just going to rewrite this equation, and wherever I have an x, I'm going to replace it with a negative 3. Negative 3 squared plus 16 times negative 3, subtract 6, which is equal to 5 times negative 3, subtract 30. Okay, now we can just simplify this and make sure that we have the same value on the left and right hand sides of the equation. Negative 3 squared is equal to 9. 9 plus 16 times negative 3, let's see, 15 times 3 is 45, so 16 times 3 is going to be 3 more than that, which would be 48, but we also have a negative here, so that's going to be negative 48, and then subtract 6. And then on the right-hand side, negative 3 times 5 is negative 15, and subtract 30. Now I have, let's simplify this part first. We have 9 subtract, let's see, negative 48 subtract 6 is negative 54. And on the right-hand side, negative 15 subtract 30 is negative 45. And then 9 subtract 54, that is negative 45, and on the right-hand side we have negative 45. So this checks out. I'm going to put a little check mark here because we checked negative 3. That works as a solution. Now let's also verify negative 8 as a solution. I'll use this nice purple color here. So now we're going to verify that x is equal to negative 8. Kind of weird that x would have two different values here, but that's the way that quadratics work. We often end up with two different numbers that satisfy the equation that we start with. So just like I did here, I'm going to rewrite the equation, but I'm going to substitute an x, or I'm going to substitute in a negative 8 wherever I have an x. So that will be negative 8 squared plus 16 times negative 8, subtract 6, which is equal to 5 times negative 8, subtract 30. Let's see, negative 8 squared is the same as 8 squared, which is 64. And then negative 8 times 16, well, negative 8 times 10 is negative 80. And negative 8 times 6 is negative 48. So negative 80 plus negative 48 will be equal to negative 128. Subtract 6. And then negative 8 times 5 is equal to negative 40. And subtract 30. Now I have 64 subtract 128 minus 6 is 134, which is equal to negative 70. And then 64 subtract 134 is equal to negative 70. So negative 8 also works as a solution. So just to review, we started off with our equation, and we converted it into a form where we had 0 on one side of the equation, and then we factored out the remainder, or what was on the left-hand side of the equation. We found out what values we needed to substitute for x to make each set of parentheses equal to 0. That told us our two solutions, negative 3 and negative 8. And then we verified our two solutions by substituting them back into the original equation to make sure that we ended up with these true statements at the end. That's solving a quadratic equation by factoring.